Okay, so I'm building this new project of mine, SQL Engine, from beginning with no prior knowledge on this topic. I've never built this project, no idea, neither theoretically nor practically, and I'm building it while learning it simultaneously with the help of Claude. So let's begin the demonstration. No, not the demonstration, actually the walkthrough. How far have I built this project? So to start with, the project has been divided into 8 stages. First is Lexer or Tokenizer. It will convert the input string or the command that user gives into tokens. Now, what are tokens? They are the smallest unit from the input string that makes some sense. Okay, so here in this image, you can see the command is select name from user where age is greater than or equal to 18, right? Now, before I tell you about the tokens, let us first talk about the data structures that we have used to make this project. So first I have declared enum class TokenType, right? Which consists of select, from, where, order, by, group, identifiers. These are actually the keywords that you use in MySQL very oftenly. We are familiar with them. Identifiers are the variables, you can say, that are declared by the user himself, like table name, column name, right? Column name like name, age, gender, they all are identifiers. Coming to the operators, GT stands for greater than, LT less than, EQ equal to, NEQ is not equal to, GTE is greater than or equal to, LTE is less than or equal to. Quite simple, right? Literals are integers, float, number. You can identify them very easily. Then coming to the symbol, comma, semicolon, L paren is actually left parentheses, likewise R paren is right parentheses, and then end of file, which determines that the input string has ended, right? Now coming back to our image. Oh, sorry, one more data type left. And the structure consists of two parameters. First is the value or the token value, and second is the type of token, which is of type token type from enum. Remember, token type from enum. Now let us get to the image. Here I have written the same command, select input from user where age is greater than or equal to 18. So what is token? Token, as I said, are the smallest unit of from the user input that makes sense, right? So we simply split all the input into different parts, like select is one token, name is one token, from is another token, user is another token, where one more token, age is one more token, and greater than equal to is another token, 18 is a numeric token, and finally semicolon, which determines the termination or the end of input string. Now corresponding to them we have token types. Select is a keyword, name is an identifier, from is a keyword, user is an identifier, where is again a keyword, age an identifier, greater than or equal to are operators, GTE, 18 is integer, as I said it is literal, integer is a type of literal, and semicolon, right? And these together, values and at the bottom I have written token type. These two will form that structure whose name is token, right? So this is the data structure. So far I have made stage 1, which is the Lexer. Here you can see lexer.cpp. this will generate token from the input string, right? These separates all the operators equal to, not, comma, semicolon, opening parentheses. Remember LPAREN, R paren. And not just this, in this program, I also came up with a bug. Here you see this. We'll talk about this bug later, but first let us run a test code and see how the code works so far. As I said, this is stage 1, which where I'm supposed to generate tokens from the user input. So let us see how the program runs. Yeah, this is the test code that I have written. Yeah, so here you can see this is the user input, right? And here select is a select. I have written select itself instead of writing keyword, but actually select is a keyword. Name is an identifier again. From is a keyword, as I said. User is an identifier. Where is again a keyword. City is identifier. Equal to is an operator, semicolon, and then EOF, which specifies end of the code. Likewise, we have one more test query and we have a few more test query, but I'd like to draw your attention into this bug in my code that I found. Here, this is the input query, but you can see that the closing quote of Delhi is missing, right? Closing quote of Delhi is missing, but still we have EQ. Still our code is running properly, right? You can see EQ operator, which is equal to right here, but there is no Delhi, right? So this exact portion, all these tokens will go to the next phase, which is parser, and it will have no idea where did Delhi go and what to do with that next, right? So this is a bug, and in the same code, I have fixed this bug as well. Lexer.cpp, here I have fixed the bug. Here you can see it. This is the bug fix. Here, if the iterator moves more than the length of the input string, if the value of iterator increases more than the length of input string, then in that case, we are supposed to throw error, because we don't want iterator to go beyond the length of input string, right? Which our iterator is going now in case of missing right quote of Delhi example, which was a bug. Let's again run the code. Yep, here you can see we got the error unterminated string literal. So this was the project. I mean, first stage of my project where I created tokens from the input string. Next stage will be about parsing the tokens, right? Generating a parse tree. Well, that won't be a parse tree, it would be AST, which is kind of parse tree but quite different to it. And I'm documenting all these project videos, so do stay in touch. I'm updating and uploading all the contents in my GitHub, as well as I will upload them on my Medium page. You can check out the source code from there. I have also updated the readme along with the bug that I just told you. You can fork this project, make your own changes, work on this, and that was it. This is Zulfer signing off.